Okay, so we're revising Boolean simplification. So if you get a Boolean equation, something like we get an equation something like this. There are a couple of approaches we can take to simplify this, and you need to be able to do both. It will tell you which one it wants you to take in the exam. Probably the easiest one initially, but more time consuming, is to use a truth table. So in a truth table, we would put all possible inputs, so there's only A and B are inputs, so all possible combinations of these, and then we'd fill in the outputs. You can do this all in one go. It's usually better to do it stage by stage, so I'll do them bit by bit. So A bar is going to be the opposite of A, so 0, 0, 1, 1. A bar plus B, which is OR, is going to be this or this, so when any of them have a 1, so there, not there, there, there. And then finally A and, not A plus B, so it's going to be that and that, where both of them are 1s. So that's this one, not this one, not this one, not this one. So we look at that and we say, does this look familiar? Is there another operation? Yes, I'm going to leave the link up, Matthew. Yeah, so this one here, and I want you to update it as well as you go. As you do your revision, you're more confident, you want to change it. So this one here, so 1 when it's 1, 1, 0, 0, 0, which single operation produces that truth table? Post in the comments if you know. In fact, what I'll do, because a few people will be looking at this later, I'm going to stick the comments here so it's part of the video. And move that along to there. Yeah. Yeah, so hopefully a few of you have spotted that is the same as an AND operation. It's only a 1 when both of them are there. So from that truth table, we can tell that A dot not A or B equals A dot B. Okay, that's the Boolean simplification. Now in the exam so far, I've never yet seen an EduCast exam where it's given you the choice of which way to simplify it. It's always either told you complete the truth table, therefore what's it the same as, or it said using Boolean identities, simplify this. So even if you get that, you do need to know this other way of doing it as well. So the other way of doing this is using Boolean identities. Now, how we approach this, there's a variety. I always advise people against just trying to memorize all the identities because there's loads of them. If I get the knowledge organizer up again and scroll down to this one, these are all the things you need to have learned. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 identities, all of which are really similar. That's not many people can memorize that kind of stuff. So I'd advise against just trying to memorize it. What we can do instead is remember a couple of mathematical things that are really similar, and then I'll just make a new one of these. No, I didn't want to save it, so I'll make a new one. There we go. What I generally recommend instead is remember a few mathematical things which are much simpler, and then just logically work out the rest. So things like this, if we've got A or 1, for example, you just think for a second and realise, well, the rule for an OR gate is if there is a 1 anywhere in it, then it's a 1. So that has to simplify to 1 because that A is irrelevant. We've got a 1 going into an OR operation. So it's going to be 1. Similarly, if we have A and 0, that's the same thing. The only way for an AND to be a 1 is if both sides of this are a 1. There's a 0 here, so it's not possible for both sides to be 1, so that has to simplify to 0. Now these things you can work out just with a bit of logic. You don't have to try and memorize them. There's a couple of slightly more complicated ones. So A or 0 and A and 1. Those ones aren't as straightforward as simplifying to 1 and 0. But this one, if you think about it, so you've got a 0 going into one side of an OR. It depends entirely on what the other side is. If that's a 0, the output's a 0. If that's a 1, the output's a 1. So that's going to equal whatever A equals. And it's the same thing here. So those ones we can get to. Some of the things are pretty obvious. If I say A or A, well, obviously that's just going to be A because it's 1 and 1 or 0 and 0. So it'll be whatever that is. Same thing for AND. That's just going to equal A. We can say, what if we take not A and not it again? Well, hopefully we can tell just logically that's likely to just be A. Because you not it once, it goes to the other one, not it again, it's back to what it was. So all of these things we should be able to get to quite logically rather than trying to memorize them. Now once you've got those, the rest of it is quite straightforward. That's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 of those 17 we've got. Now, of the 10 that remain, they split into 2 halves. So there's only actually 5 new ones, but they swap with one being based around ORs and one being based around ANDs. And it's a bit simpler. The main one, the one that has come up by far the most often in exams, is essentially a Boolean version of factorizing and expanding brackets. If we get something like A and A, actually no, that's something different. Let me do that again, sorry. We get something like that, A and B plus C. Well, if we think about just standard algebra, there's something you can always do with this. When you get this in maths, you can always expand those brackets. You can say that that is multiplied by that and by that, leaving us with A, B, oh, don't start doing this again, plus A dot C. And that same thing works here in Boolean algebra. Let's get rid of this. Yeah. That same thing works in Boolean algebra. You're allowed to do that. Now, in Boolean, however, it goes a step further. You can't do this in regular algebra, but if they swap round the ands and the ors, you can still do it. So if we get A or B and C, you can take that A or and put it into the brackets to make A or B and A or C. You can still do that. Now that's certainly not the case in regular maths, but we can do here. So that's by far the most common thing it will ask you to do if it's going to ask you to do a Boolean simplification, is spot that one of these either needs to be multiplied in or multiplied out, whichever way it does it. Okay? So if we go back to that one we did last time, so if I'll do it here. So this is the one that we looked at and did with the truth table. I said A, I don't know which way round I did it. I think I did or not a. Did I do that as a dot? I can't remember. Whatever. So it's the same either way. So if we've got something like that and it's simplified down, well, we did it in the truth table, and if this is the same one, it came to A and B. We can do it now with this algebra. So what's the first stage we need to do? Well, first of all, we check, can any of these simple identities be applied? Well, no, they can't, because we haven't got any. The outside of the brackets was a dot, thank you. So none of these applies. We haven't got any noughts or ones in there. We haven't got any A dot A or any AA. Or just realised another couple of simple ones we can add. We should be able to figure these ones out just logically. Whoops. As well. Because A or not A is always going to be 1 because it has to be one of those two. One of those two has to be 1. Similarly, only one of these can be 1, so it's not possible for that for an and to be a 1. So that's another extra one we can remember. Anyway, so over here, we then look at this one. We can't apply any of these. There's no A and not A, or any other letter not itself. There's no noughts and ones. There's no two of the same letters, so we can't do that. So then we look, can we do some expanding the brackets or factorizing back into the brackets? Well, yes, we can. We've got, let me change the color of this a second. So we've got an A dot on the outside, and that is what then needs to go into the inside. The symbol on the outside goes in with it. So I'll put this back to black. So then if I take that and put it into both sides, we've now got A dot A bar for this first one, and then put it to the second one, and we have A dot B. And that's what we've got. So now, can we apply any of these simpler systems? Well, yes, at this point we can. We have an A dot A bar. There we are. So it's not possible for that to come to a 1 because one of them will always be a 0. If that's a 1, that'll be a 0. If that's a 0, that'll be a 1. One of them will always be 0. So that's going to simplify to 0. So it'll be 0 plus A dot B. Okay. Can we take that any further? Well, up here, we've said 0 plus anything just simplifies to that anything. So 0 or something, logically, the 0 doesn't make any difference. So that's then going to simplify to just A and B. And that's what we got to with the truth table as well. So using Boolean identities, we can simplify it algebraically, or we can do it with a truth table and we get the same answer either way. But ultimately, in an exam, the likelihood is it's going to ask you either to just straight up apply, if you get a nice easy question, it's going to ask you to straight up apply. What's going on with this? There we are. One of the identities, usually for a simple 1-mark question, or it's going to ask you to do some multiplying in and out of brackets first for a second, for a 2-mark question, and then do that one. Okay? We've got any questions about that first of all? Is there anything there we're not sure about? Or I'll do a couple of other things with it. Okay, now I may have shown you this last time anyway, but I'm going to show you a question on last year's paper that caught everyone out. Right, the first one is fine. It's a 3-mark question. In fact, can we all have a go at that one? Okay, it's exactly the stuff I've just been showing you. First of all, you look, can any of those simple identities be applied? No, they can't. So then we look, can we expand or factorize it? So can we have a go at that one, please? And if you think you know what that simplifies to, can you post it in the comments? I'll just arrange it so the comments from the video for people watching later. That's not the button I meant to press. That was it. Yeah. Great question, Elliot. You know, you're one step ahead of me. That's the one that's going to cause us problems on the next one. So the idea of priority, of almost Boolean bid mass, that's something I'm going to look at in a second. Abby, no, you won't. You have to. I don't know, it depends how the mark scheme's worded and how the examiner is feeling. It may well be that, like this one here is let me just zoom it out so we can see the whole thing. So this one here, for example, is a 3-mark question. If you did it with a truth table, you may get the 1 mark for having the right answer at the end, but you definitely wouldn't get the other 2. It may be, if the mark scheme is being particularly strict, it may be a case that if you haven't shown any stuff, you can't even get the mark for that. It depends how the mark scheme works that year. For this one, the first thing we look at, well, obviously we can't, obviously at this point we can't, there's no factorizing out, no expanding the brackets, but there's a p on this side and a p on this side, so we can take that out of the bracket. We can do that expanding in reverse. So the p dot, no, do that in, probably not a good plan. So the p dot comes out, and what's left inside is q or not q. Then we look at those simple identities. We realize q or not q, well, that's a certainty because one of those two has to be a 1 and it's an or. So that becomes p dot 1. And then another simple identity, anything that is ANDed with a 1 will just depend entirely on what this is. So that will be p. So 1 mark, 2 mark, 3 marks. That's how that one was done. Okay, hopefully we all got there. And bear in mind, if you get a question like this, write it in that format. Don't go nuts and start putting equals this in one long line and doing little bits here and bits there. Write it clearly so that each line is a full simplification of the line above until you get to the final one. It guarantees you get all the marks, because the mark schemes are quite strict on making sure you follow the working out correctly. So most of the class got that, they got the 3 marks. But then nearly all of them bombed the next bit. Now, Educast made a mess of this and they offered 5 marks because they didn't see a really simple way of doing it inexplicably. But, again, this is really only worth 3 marks, but they gave it 5. This one here, this one caught people out. Can we see where we think people went wrong? Bearing in mind, this is a 5-mark question. And this appears, on the face of it, to be really easy. Now, it's unlikely a really easy question would get you 5 marks. So, there appears to be a simplification we can use straight away. What most people did was look at that and say, aha, I can simplify this. So they took that and said x or x bar is 1, because one of those two has to be a 1. Therefore, it's 1 dot y, therefore it's y. Fantastic, moved on. The problem is, that doesn't seem like a 5-mark answer. There's clearly something more to this that you need to know. Also, it's simpler than the previous question they'd just done. It's unlikely they would ask you a complex question and then follow it up with a much simpler one, simpler version of the same thing. So clearly there was more to it than that. And a few people have mentioned in the comments that it's something to do with bid mass of order of operations and what comes first. And you're right. If things are presented just like that, so they're presented as x plus x bar dot y, then there is an order of operations. And takes precedent. And will always be treated first. So even though the brackets aren't explicitly there, there are implied brackets here. And that's why we can't go straight in and simplify this bit. So knowing that, can you now follow through the simplification that you should do and get to the right answer? Okay, I've got a couple of possible answers. So Richard's gone for X or Y. Matthew's gone for X. No one else want to throw in a suggestion? Tilly's gone for 1. Okay, so we've got 3 answers, all of which are different. What does everyone else think? Right, Elliot agrees with Richard. Matthew agrees with Elliot and Richard. Okay, we seem to be getting a consensus on X plus Y, and X or Y. Let's find out. So now we know that those are in a bracket. What we have to do is multiply that into the bracket. So that, the X plus on the outside can go into there and to there. So that leaves us with X or X bar and X or Y. That's the first step. That's the big step. If you get that right, from this point it's a little more straightforward. That's the bit where people will slip up. It's a shame it's the first step. So with that done, then we look at this and say, well, X or X bar. Now we can simplify that because it's in its own bracket. And as for reasons we said before, this is a plus. One of those two has to be a 1. So 1 or something will always be a 1. That's going to simplify to 1. So keep writing it in this format. So 1 and rather, X or Y. 1 and anything is just whatever that anything is, because if one side of an AND operation is a 1, it depends entirely on what the other side is. So that's going to simplify to X or Y. So well done everyone that got that as the answer. Yeah, so it's weird. If you look at the mark scheme for that one, it gives a really convoluted solution to it, which is why it was 5 marks was given. Really, it's a 3-mark question, but it tests whether or not you can remember that the bid mass exists and don't fall for the trap of trying to simplify that, when in reality there's an implied bracket around the AND. Okay? Now the only other thing that can come up, it hasn't yet come up in exams, it might in yours because it hasn't done so far, is one other identity that we can know. Okay, let's make a quick new one. And this is this. This one, I will show you the proof from first principles because we can show it can work just using expanding brackets. But you're allowed to just quote it. You don't have to show evidence of it. And you'll see why in a second. We're allowed to know that A or A dot A and B just simplifies to A and A plus B also just simplifies to A. Okay, those are the last two identities, and we are allowed to just know that those are the case. So if you see that, you can just write A. You don't need to show any evidence of it. The reason is the proof of it is quite difficult. I'll show you what the proof is, because some people would prefer to do the proof from first principles, myself included. Looking at this, if you were just given that, if you just saw A plus A dot B, your immediate instinct would be, well, let's put that A inside the brackets. That's what we've done previously. But if we try that, something weird happens. So we go, the A goes in there, so it becomes A plus A dot A plus B. Okay, now A plus A is just A, so it becomes A dot A plus B. Hold on a minute. That's now just this. Okay, well, let's carry on. Let's multiply this one into the bracket. So the A dot goes into the bracket. So we get A dot A plus A dot B. The A dot A just simplifies to A. So we get A plus A dot B. And we're right back where we started. So this one's cyclical. If you take that and try and apply what we already know, you'll just loop round in circles forever and you'll never get a simpler expression. So these specific cases where the A is on the outside and the inside simplify to A. Now the reason they do, I can show you the proof of it. You don't need to learn this proof, but it's nice to see, is this. This is how we would do it from first principles. We'd take A or A dot B, and what we'd do is we'd look at this A and would say, well, we can AND an A with a 1, and that doesn't change it because A dot 1 just equals A. So I'm going to replace that A with A dot 1. We know that's the same because A dot 1 just equals A. Now we've got that, we can look at this and say, well, A is in both sides, so we can take it out the bracket. So A dot 1 plus B is left. 1 or B is just 1, because anything with a 1 in it and an or is just 1. So that equals A dot 1, and anything ANDed with a 1 is just itself. So that simplifies down to A. So that's the proof of why that works. You don't need to memorize that proof, it's just useful to see. But do be aware of the special case where you get A or A and B, alternatively A and A or B. Both of those do simplify down to A, but if you try and do it this method, you'll end up in a cyclical bunch of maths and you'll never get to anything simplified. So just be aware of that one. It hasn't yet come up in an exam. It comes up constantly in the A level. They love to throw that at people at A level. It hasn't yet come up in the GCSE, but it is mentioned in that list of things you need to know about. So just be aware of that special case. Okay. Does anyone have any more questions on any of this? If not, I'll give you a couple of questions to have a go at for the last 10 minutes. So, if you're happy with that, can you give me a thumbs up? If you've got questions, ask them. Big confused the work before, which one? Yesterday's stuff. Okay. So let's go back to the stuff that was open a second ago. Didn't really pay attention to where it's saved. This stuff. Right. Is it this stuff here that you're not sure about, or this multiplying out brackets stuff? multiply out the brackets. Fine. Okay, right, so let me just put a couple of questions up that other people can do, and then I'll make a new one. Right, I'll do some stuff with doing this one. Okay, so if you are happy with it, here's some to have a go at. Okay, remember to do the bid math stuff. I've intentionally left brackets out, but where they should be. So if you're happy with it, can you just have a go at those three? And then Matthew, so multiply brackets. So this is actually a maths thing. You've probably seen, I always skip over this because nearly everybody's done it in maths, and it's usually a part of maths people are quite happy with. So in maths, you sometimes get an equation that looks something like this. So you sometimes get something like that, and you're asked to simplify it. And essentially what you can do, actually that's not a good way to do it. I'll do it straight with letters. So if we get something like that, and we're asked to simplify it. And what you do is you identify that this A is multiplied by B, and it's also multiplied by C. So we can multiply it, take it outside of a bracket, so we can say that A is multiplied by B plus C. We can also do the same thing backwards. If we get the A on the outside, so we start with, I'll use different letters, P plus Q, P times Q plus R, or something like that. What we can do is realise we've got this P times on the outside. So that can multiply by that, and I'll do that so it actually points to the right thing, make it easier. So that one there. So if I pick the green one, so in other words, that P is being multiplied by Q, it's also being multiplied by that R. So that P, Q is there, and that P, R is there from multiplying that P by the R, and that plus just stays there in the middle. So taking that with the P on the outside, we can multiply that P into the bracket by multiplying it by both parts of the inside. Okay, have you done that in maths, Matthew? Are you happy with that from just a pure maths perspective? Yeah. This is exactly the same in Boolean. If you get something on the outside of a bracket, you can take it into the bracket. The only bit that's different is the operator has to go in as well. So if we take something very equivalent to this, so in Boolean, if we get something like P dot Q or R, so P and Q dot R, that's exactly the same as this. But on the outside, we've got a P, but we take that dot as well, so it's P dot on the outside. So just like before, whoops, just like before, that P dot can be applied to the Q and also be applied to the R, leaving us with P dot Q from the P dot being applied to the Q and P dot R with the P dot being applied to the R, and in the middle we just take this symbol that was in the middle before and leave it in the middle. So that is equivalent to that. So P and Q or R is equivalent to P and Q or P and R. I'll just stick the brackets around there to make it really clear. Okay, so it's exactly the same process as what you do in maths here to that one. The only bit where it's different is that in maths, you can't do this. You can't take, and I'll scribble this out because I don't want to leave this on the board but you're thinking this is a real thing. You can't take P plus Q R and multiply the P plus into the bracket. It doesn't work that way round. It does work that way round in Boolean. So if we just swap the dots and the pluses, exactly the same thing still works. So if we have P or Q and R, we can still do that bit to get P plus Q, because remember the P plus is grouped together and goes into the bracket altogether, and we can still take the P plus and the R to say P plus R, and the symbol in the middle is the dot, so that just stays in the middle, and I'll put the brackets around to make it clear. So that's a simplification that's allowed as well. Okay, so that's all the expanding the brackets is. Exactly the same technique as you use in maths to take something on the outside of the bracket and multiply it inside. We can do that. We take whatever's in the outside along with its operator and we apply it to this and to this, leaving that symbol where it was. Is that any clearer? Right, so have a go at the ones up there. I'm just going to add a bit of help, which I think people would have spotted anyway, but I'm just making it clear. Remember, the dot always takes precedence. So really, there's brackets there, there's brackets there, and there's brackets there. So can you have a go at simplifying those ones? All of them will involve multiplying into brackets. Well, I don't actually know the bottom one is that special case. Hopefully you spotted that one. So if you reckon you've got answers to them, you can post your answers here now. Worrying? Has no one managed to solve those ones up there yet? Or have you all just run off? So right, the third one's not right, Toby. The first two are. Oh, incidentally, the shorthand for this, for typing, is just to use a little apostrophe for not, because obviously you can't do that otherwise. So if I wanted to actually type something like A and not B, I'd put A dot B dash. That's the accepted way of writing something when obviously you can't type the bar across. Where's the select tool? There we are. Okay, let's have a go at this. So the first one, So Matthew and Tobias, are you the only guys that managed to answer this, or is there a problem with the chat, or are people struggling with it? Because you can have some feedback. Could you let me know if you're struggling with it? Say so. If you've done it, give me the answers. If you're still working on it, say so. Yeah, I know, but I need people to keep me up to date on this. Because if I'm asking questions, I'm getting nothing coming back. I don't know whether it's people have gone, people are struggling. If you're just working on it, just quickly type working on it. That's fine. I know where we're at. Struggling with number 2. Okay. Right, let's go through them all then. So the first one is the same format as stuff we've just looked at. So that B bar needs to be multiplied into the brackets. So it becomes A, not B bar, whoops, A plus B bar, I mean, dot A dot B. Dot B plus B bar. That's the first step. That's just me multiplying the B plus into the bracket. Then that can't be simplified. This can. B or not B is pretty much guaranteed, so that's just a 1. So that becomes A plus B bar dot 1. Anything dot 1 is just itself. That's A or not B. Okay, so that's the solution to 1. That's similar to everything we looked at so far. The second one, I was being a bit sneaky here. There's absolutely no need for any multiplying in or anything like that, because that's in a bracket already, and B dot B bar can already be simplified. That simplifies to 0. It's not possible for B and B bar to be 1, because one of those will always be a 0. So that just becomes, I'll do a different colour. So that just becomes A plus 0. Anything or 0 is just itself, so that's just A. So the second one was designed to look like a more difficult question, but in fact it was a very straightforward one. There was no multiplying out needed at all. Then the third one, that was the special case that I talked about. If you try and multiply this out, you'll end up trapped in a loop going round forever. So that's the one where the full proof requires this becoming A dot 1. Don't want to do the full proof. We're just allowed to know that that will simplify to A. So 3, we would be perfectly within our rights to write in the exam if that came up just A and expect the full marks, because you are allowed to know that that equals A without doing the full proof. Remember, that one is the special case. If we tried to do that, and I'll do it now, so A plus A dot B. If we tried to do that the way we're used to doing it, if we tried to say A plus A dot A plus B, that becomes A dot A plus B. And then we multiply that one in, A dot A plus A dot B. And that A dot A is just A, so A plus A dot B. But we're right back where we started. So you get trapped in that cycle. There's no way to solve that one. If you get trapped in that cycle, remember that the A that's on the outside and the inside, it just simplifies to that. So that's going to equal A. You don't need to show any more proof than that one. Okay, right, I'll just get, in fact, there's not much more I can do. We've done a million times over, we've done all the sample questions on this, because there's only a couple of past papers and we've done everything on it so far. All right, so that's that one. If you are feeling better about it and you want to update that spreadsheet to say you're confident on the Boolean stuff, you can. If you're still not, if you're still unsure, by all means leave it as unsure. It's a symbol for you and for me that this is worth looking at again in future. If you want to update that, please do. If not, we'll leave it to that one. If anyone's got any questions about this, ask them now. If not, we'll leave it there. So if you're happy with it, post A. Let's have a look what options we've got in here. Yeah, post one of these dancing French fries or something like that if you're happy with it. If you're not happy with it, whoops, post a question and then we'll call it a day. Oh. Okay. You'll get these things down here. What's that? There we go. That'll do. Nice. Okay, so Tilly, you're happy with it. Matthew, happy with it. That's good. Oh, Richard. Richard's posted the weather forecast. Thank you, Richard. Oh, yeah. Happy. Thing is, I'm relatively sure Abby is stood by a computer doing that. Okay. Right. Thanks, everyone. So based on the stuff on the spreadsheet, I'll plan some stuff for next week. It'll be the stuff that's not very well liked on there. Let's have a quick look at that spreadsheet, see how up to date it is. It's one of these. Okay. Right. So yeah, looking at this at the moment, stages of compilation, utility software, protocols. That was a things like SMTP, FTP stuff that we did recently. Embedded systems, that's actually just one line. You can do that, it's not difficult. Architecture, understandable, that's a tough one. And graphics and sound, they're the main ones causing problems. So I'll pick one of those for next week. Have a go at, and I will see you all then. Thank you very much.